This is Algebra 1, Lesson 25, Practice. We're going to be solving two-step equations. So if I knew what x was, I would multiply it by this 2/5 and then I would subtract 3/10 from it. So we're going to do the opposite and in reverse. I'm going to add 3/10. That'll make that go away. Bring down what's left. And I need to do this addition. So it means I'm going to have a common denominator. Think about 2 and 10. 2, 4, 6, 8, 10. 10 is going to be my common denominator. And I would have to multiply by 5. So 5/10 and 1/2, that's the same, right? Let's add 3/10 to that. And we're going to get 5/10 plus 3/10 is 8/10. And we could simplify that if we wanted to, right? At this point, that might make it a little bit easier, or you don't have to if you don't want to. We could just simplify at the end, but that would be 4/5. Now, what would I need to do here? Well, they are multiplying by 2/5, so I need to divide by 2/5. But remember, dividing by 2/5 is like multiplying by its reciprocal. And notice, I'm just really trying to get this to go away, right? And if I multiply by the reciprocal, it causes everything to cancel out. So we just end up with x. But we need to come over here and make sure we do exactly the same thing on this side. And then we can cancel here. How many 5s in here? 1. How many in here? 2. How many 2s in here? 1. How many 2s in here? 4. Right? And then we multiply straight across and we get 4 over 2. But we could have canceled one more time, couldn't we? We could have canceled a 2 here and a 2 out of there, but I didn't notice. But that's okay, I can do it right here. Let's simplify that. Divide by 2 for both of them. And I end up with 2 over 1, which is just 2. So x is equal to 2, or 2 is equal to x. And you could have right here 4 divided by 2. That's just 2. So a lot of different ways to look at it. All right, example B. I'm going to undo the addition first. I see that I have fractions that are being subtracted, right? So I'm going to need to get a common denominator. 7 and 14, that's just going to be 14. Multiply that by 2. Moving kind of quickly because I know you've already done these, haven't you? Okay, and you can stop the video if you need to. All right, I've got 5/14 minus 6/14. How am I going to do that? There's nothing to borrow from. Well, it's just 5 minus 6, right? 5 minus 6. If you take away 5, you're down to 0. You take away 1 more, you're at -1. So 5 minus 6 is going to be -1, and the size of the pieces are still the same. It's a 14th. So 5/14 minus 6/14 is -1/14. All right, now I've got 2 and 1/4, and I'm going to have to divide by it. Now, I like the little trick where you multiply by the reciprocal, but you can't take a reciprocal here because I've got a mixed number. So let's fix that. Let's change it. 2 times 4 is 8, plus the 1 is 9. So I'm going to rename this 9/4. That's the same as 2 and 1/4. And just copy everything else down. Okay, I really encourage you, copy everything down so you don't lose anything. All right, then I'm going to multiply by the reciprocal on both sides. And then I'm going to cancel. And that makes everything cancel out over there. And let's see, these two have a 2 in common. And then I can multiply straight across. -1 times 2 is -2. And 7 times 9 is 63. So the answer is -2 over 63. C. Now, the order is a little different here. We've been used to the variable being on the left side of the equation, but it doesn't matter, right? You can switch it around. Like if I said 2 plus 5 equals 7, You could say 7 equals 2 plus 5. It's the same thing. So we'll learn a name for that later. So we can still do it the same way. We need to undo the addition or subtraction first, right? If we knew what x was, we would multiply by 20, and then we would add this negative 4. So we're going to add a positive 4 and divide by 20. I said 4, 1.4. So let's add 1 4/10 to both sides. Okay, now we're going to need to get rid of the 20, so we're going to divide by 20. Okay, here we've got 2.6 divided by 20. We can do that. 20 won't go into 2. Bring up the decimal. 20 will go into 26. It'll go in there one time. And then 20, let's see, I got to add a 0 and bring it down. 20 will go into 63 times. And we'll get 0.13 or 13 hundredths. Okay? And it might be fun for you to check these using a calculator. You could take this value, multiply it by 20, and then add a negative 1.4 to it, or subtract 1.4, and you should get this answer in your calculator. That's a fun way to check them. All right, D. If I knew what x was, I would multiply it by 0.7, and then I would subtract 0.4. But I don't. So I'm going to add the 0.4, the 4/10. That's going to cancel out. Let's quickly come over here to keep it balanced. I'm going to get 0.56. And over here, 7/10 x. Now I'm going to divide both sides by 7/10. And I get x is equal to, I'm going to come over here and do this. I'm going to move this once, bring it up. 7 will not go into 5, but it'll go into 56 8 times. So we get 0.8 or 8/10. Now, there's another way to do this. You can see here, I wanted to show you this, because some of you may enjoy this way a little bit better. When you've got this fraction, this division with decimals, we could have just went ahead and multiplied the top and the bottom by 10, right? And that would have given us 5.6 divided by 7, okay? And then you may have been able to see the answer a little bit better. I mean, it's the same thing as doing this, because here's where we multiplied by 10, right? And then you could do your division, or you may notice, hey, that's got to be 0.8 because of your multiplication facts. But either way you choose to do it, that'll be fine. But your answer is 8/10.